Thanks for coming back. Here goes part 4. Alright, I'm going to start work on the crankshaft. Initially I start out with cutting my music wire, the 1/8 music wire I'm going to use for the crankshaft to match the pattern's length. And then what I like to do is take a piece of tape along the music wire. It's actually a little longer, but I'll trim it down. I need to cut it right here. Oops. I'll have to move it once, but it's fine. That's the start of our crankshaft. To figure out the size of my counterweight, I'm going to use these small oak squares, and I'll balance out my balance scale here with the weight that it's going to be to counter. First, a piece of the crankshaft, that's going to be, oops, well, we'll put that on second. I have to sleeve balance for the displacer. The crankshaft, oops, and the counterweights on the crankshaft will be made out of the same thickness of wood. And the distance from the center of gravity determines the eventual size. But we need a starting point for our calculations. These are basically 20 millimeter squares, and these are 10 millimeter squares. Scale there. That's a little extra on that side, and that's fine because there's a little more weight that's going to be on for the connecting piece. So I basically have 3 20 millimeter squares and 3 10 millimeter squares. Now, based on the results from the balance scale, I've taken the areas and reduced them, with some rough guesses and stuff to be the components of the crankshaft. So I'll cut those out from the 1/4 inch oak. Let's see here. Start by guys in. That is essentially how the crankshaft is going to assemble. Once everything's working and I have it all sized up right, I'll pull these out, maybe line it with a little epoxy, then put it all back together. Put the crankshaft in place. Do that. So, bring it around a little bit. Slide that in. Get it lined up. I'm going to make the connecting rods or at least a connecting rod for the displacer at this point. It's going to be made in the same manner, it's just longer, as the one for the Phoenix engine. Okay. Have the holes drilled out with some of these very tiny drill bits. Basically matched to the size music wire I'm going to use. Actually, it should be a hair smaller so it holds them in there when I put it in. I'm going to cut it out on the scroll saw. There we have the resulting connecting rod for the displacer. So we'll start by putting the bottom piece on. Zoomed in quite a bit here. Alright. What's this piece? This. There's 2 parts to it. Go there. Just like that. That's how it'll attach, and that's how it'll attach onto the crankshaft. All right. Set up this, I don't know, I guess I'd call it kind of a clamp to allow me to attach and remove the bellow as needed. It's kind of bulky and clumsy. Probably won't be the finished product. But once I've established a good design that works, I'll probably just come back and glue it right onto the post here. This is the first run of the engine, attached directly to the candle stand. It's running completely silent, which is nice. I did not at this point notice that I put the crankshaft together wrong. As a result of that, I assumed the problem with it not running smoothly was the bellow. While the bellow was a little springy, the crankshaft was the primary reason the engine was not running smoothly. Fan it a little bit, attached directly to the candle stand. It's not producing quite enough heat to break in the bellow. There's a lot of springiness in the paper. So I'm going to make the bottom now. That'll attach right on this, allowing me to put it on a much higher heat source. This is the pattern I'm going to use. It'll just be a flat plate with 3 attachment points. So I'll get that cut out. Stick out just a little bit. Tap it in. Just like we want. Alright. Try to line this up as best we can here. is running alongside of my other engines. The original beer bottle engine. New one. Stove's running a bit on the hot side here, so she's overburned. The Phoenix engine, as it's ran probably 50 hours so far, just keeps getting faster and faster as it gets a little looser in the mechanism. I'll probably put some bearings in it, because the linkage is getting a little noisy. Granted, it's moving pretty fast. My first attempt at the bellow has proved to be too springy, and it's slowing the engine down, making it so it only runs decent at pretty high temperatures. So I'm going to remake the bellow. I had some of this rather thin tracing paper, so I'm going to try and make a new bellow out of that and see how that performs. I'm going to make a flywheel for the back side, and then I'll do a fan for the front. I like to kind of make it themed, so instead of doing more of a wheel, I'm doing arms holding beer bottles. So it kind of goes along with the theme of the engine. Got it cut out here. I just need to separate it from the wood now. Usually it doesn't hold too tight. So we got tape on there and stuff yet. Little side note, in the plans I will have a couple other patterns for flywheels. This was to be an arm holding a mug of beer, but my family seemed to think it didn't look like a mug of beer, more like a toolbox or something, so I did the beer bottle with an arm holding a beer. So I'll take the tape off. I'll make a little wooden mount, just like on the Phoenix engine. Just kind of glue that on. It's easier than some other methods. And it just kind of holds on with friction. Here it is on my stove, running with the beer-themed flywheel. I haven't made the fan yet. I have finally noticed that the crankshaft was put together wrong and corrected that, so it's running a lot smoother now. At this point, I'm going to work on refining the bellow operation, the connecting rod for the bellow, and a fan for the front. I want to try and get it to work on a slightly lower temperature range. Thanks for watching.